right, so I am Kirsten Jones. I am the API Ninja at 3Scale. That was my requested title. I actually have swag to I was planning on bravely tossing this into the audience if you guys ask good questions, but I think that when my minion gets back, my API Ninja in training, I will have her bring them out because I don't actually want to cause any harm to anybody here. So I am a developer evangelist at 3Scale. We provide API management services. We're located right here in San Francisco, and we have offices in London and in Barcelona as well. Previously, I just started at 3Scale. I'm really excited at the opportunity to sort of help people as a whole get better at using APIs and being successful with them. So previously, I worked at Netflix and LinkedIn, and I have lots of experience helping developers try to work with APIs that they found frustrating or difficult. I am a language polyglot, so no, Ruby is not my first, nor my second, nor actually my third language. But, and I may have given this talk in other languages before, but I promise there's lots of cool stuff here for you. In fact, as I was working through this talk for Rails, I was really impressed with how much of the REST fundamentals were used in designing Rails. And so while I'm talking through what I'm talking through tonight, you may find that you get a little bit more insight into what the Rails folks were trying to do when they put together the framework in the first place. So where I came from, I am one of those people who doesn't have a computer science degree. I have a BA in philosophy from UCSC. Uncle Charlie's summer camp, for those of you who went there. And I started working, I actually worked at SGI for a while. I went to the W3C conference in '93 in Darmstadt. And I've been working with the web since then. But mostly what I love to do is help people solve problems, find barriers that are in people's way of getting done what they want to get done, things that are frustrating them, and remove those barriers so they can do the amazing things that they want to do. So that's what I love to do, and that's what I'm hoping to do here today. So this talk, it's actually a little closer to HTTP deconstructed, but what I discovered when I was working at Netflix and at LinkedIn was that a lot of people who were incredibly intelligent programmers, they would come onto the forums and they'd be like, so I tried to get a profile and it didn't work. And I'd say, what did the HTTP stack look like? And they'd say, what? The what? A lot of people are installing these libraries and they're trying to use them, but they don't understand what the underlying technology looks like. Historically speaking, APIs have been for computers talking to computers, and there hasn't been a good way for us to sort of inspect what's going on. One of the great things about REST web services is that it's not a black box. You can inspect it, you can see what's going on, and if you have a little bit of understanding about how HTTP works, you can solve a lot of problems without having to wait for those forum people to get back and answer your questions. So I'm going to give you a little bit of that information. I'm also going to show you a couple tools that you can use to inspect your own calls and figure out what's going on. Get on with doing the awesomeness that you want to do as opposed to trying to beat your head against the stack of the request. So I'm going to talk about a quick overview of HTTP, how REST is layered on top of that, and then I'll go over debugging tips and techniques. And if you promise to be nice and not ask me a bunch of Ruby-specific questions, I'll take a lot of questions at the end. And if you ask good questions, I will have my lovely minion here bring you, oh, I didn't show you the swag. You don't know that you need it. Your very own API Ninja. Super cool. Okay, so I see that most of you are very polite attendees and you don't have your laptops out. But a few of you have your laptops, and that's cool because I also like to poke at what the people are talking about. If you want to play along, you're welcome to. You can go ahead and install one of the HTTP Sniffers. HTTP Scoop only works on the Mac. It's gorgeous. It looks totally Mac-y. It doesn't support SSL. You have to use something like Charles, which is really kind of complicated to use as SSL. So you can get that at www.toughcode.com. Or for Windows, you can use Fiddler. It's not as beautiful because it's a Windows product. But on the other hand, it does support SSL natively, and it gives you a lot of great information. If you use Linux, I didn't put it on the screen, but you can use Wireshark, which is uglier than anything, but is more fully functional than either of these. So, and I'm going to talk through what HTTP sniffers do and how they can help you figure out what's going on. Okay, HTTP. Most of you probably know this stuff. It'll be pretty quick. For those of you who don't, HTTP is the hypertext transfer protocol named by people who like to camel case things and throw capitals in the middle of things. The basic way to describe it is it's used for conversations between web clients and servers. And it supports verbs for get, put, post, and delete. There's a few other verbs as well. They're not as widely used, not as supported by as many clients. But try to keep these in mind because this is interesting in how it maps later on to the REST verbs. And one of the cool things is it includes support for query parameters, which allows you to add a little bit more information to a request. It also includes some excellent error handling. Okay, so let's talk through this really quickly. We have a request and a response. The client sends a request. It has a method, which, as I said, is one of those verbs, get, put, post, delete. There's a URL. That's the identifier for the thing. What's really cool about the way REST uses HTTP and the way HTTP works is the URL is the identifier for the resource you're trying to get. Some headers giving some meta information about what you want, parameters optionally, and sometimes a body. Server replies or response. It's always going to have a status. Usually it's going to have a content. For instance, with a delete, it's not going to have a content. But in general, you're going to get some content back, and then some headers telling the client about information about that resource. This is one of my favorite slides. I had to clean it up a little bit after I gave this talk at OSCON and got scolded by someone. But this is very helpful for those people who haven't spent a lot of time looking at this. 500, we messed up. 400, I think a better way to describe it is, huh? What? 30X is ask that dude over there, and 20X is, that's cool. One of the cool things about 40X is as a server, the server has the opportunity to provide a lot of interesting status codes. The authentication one's 401 is different than a 403. One of them is the authentication isn't allowed. We've got 404 where it's not there. We have 418, which, anybody know what 418 is? I'm a little teapot, that's right. So there's a HTTP status code for just about everything. Yeah, you gotta say, you think that W3C doesn't have a sense of humor? I'm a little teapot. Made it into the spec. Okay, so again, I'll try to go through this quickly because this stuff on slides is not beautiful, but it should give you an idea. So we're asking for stuff from Google. Your browser sends all of this crap all of the time. This is one of the coolest things you can do with a sniffer is to just run your browser and see what's happening. Find out what kind of information the browser and the server are passing back and forth about you. You wonder what those cookies are and what they're storing? This is really helpful. So this is the request. And here's the response. So there's a bunch of data, but other than the stuff that you see in your screen, you've got the status, you've got the content, which is a bunch of HTML, but we also know what the content type is of what's coming back, what the char set is. That actually tells the browser information about how it could render it. It may optionally set a cookie to store information later. Anyway, so that kind of gives you an idea of the volume of information that goes back and forth when all you're doing is clicking on things in your browser. And, sorry, this microphone and I are not great friends yet. So this is HTTP Scoop. One of the reasons I really like it is that it's really quite friendly. The default is it just shows you the things that are happening, and when you click on it, it shows you, here's the response line, including the status, here's the URL. When there's parameters, they're going to be over here. Was there a body in the request? No, it's a GET, so there wasn't any body. How big was the response, and what was the response time? This is actually even useful if you're just trying to do some troubleshooting on your very own server. Like, why is my server not doing what I'm expecting? Well, let's get some data. Let's just poke around. Of course, you can run tests. You can run automated systems on it. But sometimes just poking around at it and getting some data about that can give you information that will help you solve a problem. OK, so now we have some headers. This is that fabulous Gmail request, and that shows you the headers. But what's cool is it shows you the request headers over here, the response headers over here. Again, giving you information so that you can determine why things aren't working the way you expect. OK, so I'm going to move on. Wow, everything's so big all of a sudden. OK, so as I was saying, REST APIs leverage HTTP. And for those of you who have used Rails significantly, you probably noticed that Rails uses the same sort of a language. When you tell it how to do a route, you tell it which HTTP verb to use, essentially. You have a get, you have a delete. For error codes, it uses HTTP status codes. For request parameters that you need for any API, it leverages the query parameters. And for response types and configuration, it leverages headers. One example of this that's really useful is a lot of APIs actually support XML or JSON. One way for them to have the clients tell the server what they want is to send a header that says, I want XML or I want JSON. That is exactly what those headers were designed for, is to send meta information about the request that says how that information should come back. That's used most frequently. It's been used historically for languages and other things like that, but there's no reason you can't leverage that framework to make your API smarter. So, having said that, we'll look at an example REST request. There aren't a lot of APIs that do not require very tricky authentication, but Tumblr allows you to read requests without doing the OAuth dance. And since we have a limited amount of time here tonight, I'm not going to try to describe OAuth. So you're making the sample request. The API key was the only parameter that's going in. It's got the request URL. As you can see, it looks just like a browser request. You can see that under headers, the request headers are very simple. Your API client is very rarely going to send extra headers. It's only going to send things it needs to send. And in this case, it doesn't have much to say. It is saying what kind of user agent it is. That's just because curl is sending that. We actually, if we could send it with using a different functionality, it wouldn't even put in the user agent. But the response headers are still coming through. We still see that the content type is application JSON. It's giving us some internal Tumblr information and the date of the request. And you can see the response text is much easier to see in this screen. And this is just a JSON response. Notice one of the things that APIs tend to do is they shove some meta information in the request, but you're still always going to get a status code back from the server. The server doesn't know how to respond to you without giving you the status code. OK, so that basically is a whirlwind description of how HTTP works, how REST works, and is layered on top of it. Most versions of this talk, when I have a whole hour to talk, I go through OAuth. OAuth is a pain. There are excellent libraries out there. And I cannot possibly do anything in 10 minutes with somebody who doesn't know OAuth other than horribly confuse you and make you never want to do it. So I promise you, if you need to use a web service that uses OAuth, there is a fantastic library available. I know that the Ruby libraries, especially, not just OAuth libraries, does anyone know? There is somebody who does a great job of making API libraries for almost every API in Ruby. And he supports them, and he does a fantastic job. Yes, Penguin, that's him. Right, Pengwynn. So he made I know of him because when I was at LinkedIn, he made a great LinkedIn gem, but he also goes out of his way to make sure and find APIs that need Ruby love and give it to them. So you always want to try to find those libraries. And I'll mention more about that in just a moment. Okay, so troubleshooting API calls. First, use HTTP Scoop or Fiddler or Wireshark if you don't have a Mac to understand your calls. I encourage you to watch your traffic on browsers. Watch your traffic with your clients. Spend a lot of time looking at how traffic works so that you really understand how that HTTP stuff works. If you find a call, a known good call, and you have a call that seems the same to you but isn't working, there is something different about it. The server does not have something against you personally. I know it feels like it. When you're trying to get stuff done, you're like, oh man, this server's just got it in for me. It doesn't. There's something different. You may have misspelled one of the parameters. You may have put things in the wrong order. I'm going to talk about using libraries and some of the reasons for that in just a moment. So compare it against a known good call. That's your best strategy in almost all cases with APIs. Simplify your request. Sometimes you've got a parenthesis in your call, or you've got a space in your call, and the library that you're using or the code that you have isn't gracefully handling that in the way that the API expects. So make it the simplest call you possibly can. See if it works then. Binary testing. It's always the best way to go about it. And then, so here I'll break off and tell you a little story about asking good questions. One of the things I always want to do whenever I'm trying to support a developer or help someone with something is help them right away. They wouldn't be asking me a question if they weren't frustrated. So they're already frustrated. And what I hate the most is when they like ask me a question, and then I ask them a question, and then they ask me a question, and then I ask them a question, they ask me a question. So when you ask questions, especially on Stack Overflow, where people are not the kindest, always, you want to ask good questions. So what does a good question look like? Stack Overflow has a great description, but it's not nearly as amusing as mine. So first, I'll tell you how you want to ask the question, and then I'll tell you why. So, ask a question. I did A. I expected B to happen. To my dismay, C happened instead. Okay, so that seems obvious, right? Why would I have to put B in there, though? Because I did A and then C happened. In fact, why do I even need to say A? So, I jumped off a cliff. I expected to sprout wings and fly. To my dismay, I plunged to my death instead. Not really a bug in gravity. It's actually, I misunderstood the system. And what I want users to realize is that's still a bug. The job of the people supporting the API is to make sure that your expectations are set correctly. So if you thought that you were going to sprout wings and fly, then probably somewhere in the documentation there should be a note that says you're not. Probably it's still the support person's problem, but you can help them help you. And you can help them help you right now instead of 17 iterations down the road when you're both ready to tear each other's hair out. If you put all of these things out right away. especially on Stack Overflow with the less kind people. But in general, this is a really good way to make sure, and it also helps you, because sometimes you're like, I did A, I expect, oh. Never mind. You know, I mean, sometimes you see what your problem is when you try to explain it in a way that really makes it clear. You make it clear, and then you realize, right, that's not how that works. Okay, so troubleshooting API calls, that's one thing I can help you with. But the second thing is my favorite part, preventing preventable problems. So use existing libraries, code, and examples. At some point in your life as an API developer or API user, you may think, I'm going to write an OAuth library. Don't. And then you might think, no, really, I'm the person who's going to do it right. Don't. Just don't do it. There are fantastic libraries out there for all of the big languages and most of the little languages, and certainly Ruby is one of the big languages that has fantastic libraries. There are so many rules about OAuth. Like, did you know? Here, let me tell you one of the things in OAuth. Because of the way the signatures are generated, the parameters, not only do they have to be in alphabetical order, but if you have multiple parameters of the same name, they have to be in alphabetical order of the values, or the signatures won't match. Really, seriously? There's a corner case you're not going to test for until it breaks, which it will, because you don't want to write your own OAuth library. You have great ideas. You have fantastic applications inside of you. Spend your time on that. Don't spend your time rewriting OAuth libraries. Code defensively. Okay, we all hear that all the time. Code defensively, that's a thing they say in those computer science classes I didn't take. But we all know that we're perfect, right? So since we own the whole stack, top to bottom, there's no chance we're going to actually hose ourselves and cause something to break, you know, elsewhere. But no, okay, well, if it were true that we were always perfect and never made any mistakes, even so, you are no longer in control of your whole stack when you're using an API. You have to assume they're going to mess you up. So you have to assume that just because that field has always shown up before in this JSON representation, if it doesn't say in the spec that that's what's going to happen, it could go away. It could disappear. And if it always had a value before and then was empty if it was 0, that's not necessarily true either. So you want to test that. Does it exist and is it 0? Does it exist and does it have this value? Assume that they're going to change everything they don't say they're going to change, and also the things they say they're not going to change. Check those two. Test defensively. Write tests. Write your integration tests so that they also cover the API stuff. Make sure that when you write those tests, you're not just testing your own code, you're testing the code with the APIs on the back end, so that when they change something and it changes and it breaks your stuff, you know right away. That's the test frequently part. And handle errors gracefully. One of the things that is most useful is to pass those errors back. So obviously, most things you don't want to pass back to the user, but if you can log them somewhere on your own server, so that when you ask for help from the support team and they're like, well, what did it send back? And you're like, I don't know. They're going to be like, yeah, come back to me when you can recreate it and show me what the stack looked like. So save yourself that trouble and go ahead. What was the call? What was it to? What were the parameters? Whose key was it? What did it do? And what did the error look like? And if I know anything about everything, just put it all in there. You'll thank yourself later. Or you'll run out of disk space and you'll blame me. But that's okay. Disks are cheap. Frustration is expensive. So that's it. I will give you guys an opportunity to get ninjas in a moment. So this is me. I am Senator on Twitter. Oh man, I always mean to tell you all to say nice things about me on Twitter so that my boss will be happy. I am Kirsten at 3scale.net, the API Ninja. I will be giving a talk on Intro to APIs at the API Strategy Conference here in San Francisco. If you have interest in coming to that conference, come after and see me, and I will pass you along to our conference organizers. My website is princesspolymath.com. I am Princess Polymath. And thanks so much to Twilio for hosting. It's very expensive to feed all of these people and keep people here after hours, and I just want you guys to remember and appreciate how awesome it is when they do that. So thanks very much, and I will ask questions from all.